All right, guys, so we're starting a new chapter today. We're going to be writing equations of quadratics. The first one, 15.1, is over the root form of quadratic equations. The first thing you need to know is what a linear factor is an expression in the form y equals ax plus b. Now, you've seen these before when we've been factoring quadratics and you get these two things. You know, we might have like x minus 4, x plus 2. Those are in that form ax plus b. So what we need to do on the next one is find the linear factors of x squared plus 3x minus 4. We can do that with the swing method. I can find the sum of 3 that has a product of negative 4. So I need to think of numbers that give me a product that have a product of negative 4 but a sum of 3. The things you can think of would be 4 and negative 1. 4 times negative 1 is negative 4. 4 plus negative 1 is 3. So I throw those into my linear form factors. I have x plus 4 and x minus 1. Now our y is 1, so we don't have to do any division, so those are our factors. The next one says, how would you use these to find zeros of a function? Well, that's easy. Set them equal to 0. Set them equal to 0. So we could do that. We'd have x plus 4 equals 0. We could subtract 4 from both sides, and you get that x equals negative 4. Notice it's the opposite of what we got earlier. Then we can do the other one the same way. We have x minus 1 equals 0. I can add 1 to both sides, and I get x equals 1. So that's how you find zeros. We've been doing that. Now, what we're going to do is write these things in a root form of quadratics. The root form equation is f of x equals a times x minus r1 times x minus r2, where r1 and r2 are the roots or the zeros. So the things we just found here, those are the roots or the zeros, okay? So we're going to do a few problems today. It really doesn't take very long. Pay attention. It should be a pretty easy day. So let's go down to the first example. It says, write the equation of a quadratic function with roots of negative 2 and 3 and a y-intercept of negative 12. So there's a couple of things we have to realize here. They gave me the two roots, or the zeros, and I know that those zeros are going to have to go into these equations, okay? So that's the first thing I'm going to do. I'm going to rewrite it. I have f of x, or let's just say y. F of x and y are the same thing. Y equals, I don't know what a is yet, but I have x minus, let's see, negative 2 is my first one. Then I'm going to have x minus 3, my second one. Now I have a boom-boom situation going on in here, so I'm going to rewrite that. Y equals a times, oops, not a again, x plus 2 times x minus 3. Now the last thing we need to do is find a, and we're going to use our y-intercept for that. Remember, if we have a y-intercept, that's where it crosses the y-axis, meaning it's a point where x is 0 and then y is something. In this case, it's negative 12. There's my x, there's my y. Let's just plug them in. So now I have negative 12 equals a times, well, x is 0, so 0 plus 2 times 0 minus 3. Now all we have to do is solve for a, and we've got our equation. Now I'm going to simplify this again. I've got negative 12 equals a times, well, 0 plus 2 is 2. 0 minus 3 is negative 3. Come up here a little bit. So now I can fix that. I have negative 12 equals, well, negative 2, or 2 times negative 3 is negative 6, and then we have our a. I divide both sides by negative 6, and I found that the a equals 2. So I just go and plug that in for a here, and I have my equation. Y equals 2 times x plus 2, x minus 3. And guys, that is all there is to it. You've got to plug in the things where they go. You're going to have to solve for one variable, but if you have a y-intercept, guys, the x is always 0, which makes it a lot easier. Let's go ahead and try another one. It says, write the equation of a quadratic function with x-intercepts at 4 and negative 4. Now, I didn't say roots this time. It said x-intercepts, but you have to remember those are the same thing. I'm going to write roots up here, or you could even write zeros. You have to remember those are the same thing. So I have 4, negative 4, and a y-intercept of 6. So I'm going to go ahead and fill out my equation. I have y equals a times, I'm going to have x minus 4 times x minus negative 4. But I have a boom, boom. I'm going to rewrite it. So I have y equals a times x minus 4 times x plus 4. So I have it all cleaned up as much as I can, but I have a y-intercept. I know that's the point 0, 6. That's my x, and that's my y. I'm going to plug them in. So I have 6 equals a times, we have 0 minus 4 times 0 plus 4. Now, guys, you may be able to skip the step I'm doing right now and go ahead into the next one, the one that says 6 equals a times negative 4 times 4. You don't need to show that whole step, but it might help if you do. I'm going to come up here a little bit. I have 6 equals, I'm going to have negative 16a. Now I can divide both sides by negative 16, and I get a equals 6 over negative 16. Now we can simplify that a little bit. I can take 2 out of both, and I get negative 3 over 8. So now I can plug that in for my a. I get y equals negative 3 over 8 times x minus 4 times x plus 4. And there you go. All right, so you can see the process is the same. It's not going to get any trickier. Let's go ahead and look at another one. You might try it by yourself first. It's the same question. Write the equation of a quadratic function with zeros of negative 3 and 2 and a y-intercept of negative 1. So hopefully you tried this one out yourself. Let's see, I'm going to have y equals a, and let's see, I'm going to have x minus negative 3, x minus 2. I can clean that up. I have x, I have a boom boom plus 3 times x minus 2. They told me the y-intercept is negative 1, so that's the point 0, negative 1. There's my x and y. Let's plug those in. Negative 1 equals a times 0 plus 3 times, oops, almost put x, 0 minus 2. Now I can clean that up again. Negative 1 equals a times 3 times negative 2. So that's negative 1 equals negative 6a. So you can see the process is the same, and you may be able to skip some steps now. I divide both sides by negative 6, and I get a equals 1 over 6. Could be negative 1 over negative 6, but remember that would be a positive. So I can plug that in. Y equals 1/6 times x plus 3, x minus 2. Now you may remember the order doesn't matter on these two guys. If you switch those, wrote it x minus 2, x plus 2, that's the exact same thing. So there's our answer. Now example number 4 changes things up just a little bit. It says write the equation of the quadratic function in standard form for the parabola shown. So standard form is a little bit different. We may have to do some multiplication. First thing I need to realize is they didn't actually tell me the zeros, but they're right here. I can see it on the graph. It looks like I have one at negative 1 and one at positive 1 and one at positive 3. It also told me f of 0 is negative 12. Well, that would mean x is 0, y is negative 12. So that's my y-intercept. So let's do the same thing we've been doing. Y equals a times, let's see, it's going to be x minus 1, x minus 3. I can go ahead and plug in my stuff now because it's already fixed. See, my y is negative 12. That equals a times 0 minus 1, 0 minus 3. Now I have negative 12 equals a times negative 1 times negative 3. So I have negative 12 equals 3a. And then from there we divide, and we got our a equals negative 4. So we're going to plug that in over here. Y equals negative 4 times x minus 1 times x minus 3. Now it said in standard form up there, guys, that's going to be the ax squared plus bx plus c form. So that means we're going to have to do some distribution here. We're going to start here. I'm going to do the distribution. I'm going to keep the negative 4 outside. And let's see, I'm going to have x times x is x squared. I have x times negative 3 is negative 3x. Negative 1 times x is negative 1x. And negative 1 times negative 3 is positive 3. Now I'm going to clean that up a little bit real quick. That's negative 4 times x squared. Negative 3x minus x is negative 4x plus 3. So I'm almost finished. I have to distribute the negative 4 and I'm done. Oops, didn't mean that last line there. So let's see, I'm going to have negative 4 times x squared is negative 4x squared. Negative 4 times negative 4x is plus 16x. And negative 4 times 3 would be minus 12. So there's your answer. All right, guys, this is pretty straightforward. You need to get your homework done. This is a pretty short chapter, so the test is coming up quick. Make sure you get your practice in. If you have any questions, just let me know. Good luck.